Hey Karen, so we're looking at mass percent today, and so as the problem says, diazepam is the addictive tranquilizer, also known as Valium. Its simplest formula is C16, H13, N2OCl. Calculate the mass percent of each element in this compound. So this is a pretty simple problem once it's explained conceptually, I think. So it's pretty easy to look at this and be like, okay, well the percent, so like there's 16, 13, that's 29 if you add them, plus 2, 31, plus one more of each of these, that'll bring you to 33. So you think, oh, 16 out of 33, because there's 33 total molecules, right? And 16 carbon molecules, so you'd be like 16 out of 33, that's about 48%. The problem is that it says mass percent, so each one of these has their own different type of mass. Each element has what we call a molar mass, right? So what you're gonna do is, and let me get to my notes app. So let's write out the thing. C16, what was it, H? I already forgot it. H13 N2OCl, right? So H13 N2OCl. And I'm sorry about my handwriting, I just got this out. So what you're gonna do is, I think the first thing that you should do is find the molar mass of the total molecule, right? The big element, the diazepam or Valium, whatever you want to call it. So you're gonna find the mass of all that. So we're gonna look at our periodic table and see that C has a molar mass up here of 12.01 at the top right there, okay? And you're always gonna round to 2 digits. So if we bring this down here, 12.01, and there's 16 of those, so 16, plus H, so H has a molar mass of 1.01, so 1.01 times 13 plus N2, N has a molar mass of 14.01, so you're going to bring that over here, 14.00, undo, 01, and there's 2 of those, so times 2 plus O, we know that O has a molar mass of 16.00, and let's look at Cl. You'll notice Cl has a molar mass of 35.45. So there's one of each of these, right? So 16.00. Oh man, I ran out of space. So it was 35.45, right? 0.45. So you're gonna add those all together, and you can take the time to do that. You can pause the video or whatever you want, and that will be. Give me 1 second. I'll do it. So that's going to be 284.76 equals the molar mass of diazepam. Right? So now it wants the mass percent of each element, right? So you're going to find, how much of this mass, what percent of this mass right here is made up of carbon. And then you're going to find how much of this mass right here is made up of hydrogen. And the same thing going forward, right? So C16, right? So let's go back to carbon. So 12.01, let me zoom in, times 16 equals, I don't remember, 180? 12.01 times 16, it's going to be 192.16. over that, because you're finding the percent of the total mass, right, for each element. So that divided by 284.76 is going to equal 0.6748. And since you know it's a percent, that's going to be 67.48%. And so what that means is that carbon in this compound element or compound molecule represents the mass of all the carbon molecules, the 16 carbons, is 67.48% of the entire mass of this thing. So then you're going to do it one more time with hydrogen. So I'll do hydrogen and then I'll let you do the rest. So hydrogen, the molar mass is 1.01 times 13. So it's obviously 13.13 divided 284.76. Let me check that on the calculator. That's 0.0461. And so usually you're going to go out to 4 digits because you want this to be a percent, right? And you want 2 digits after the percentage, or after the decimal. So 4.61%. So that means, once again, of the entire mass of this thing, of the 284.76, I think it would be grams, I'm not sure, 4.61 of it is hydrogen. So you would say 4.61 equals H, and this equals C16, right? And so as you go, these shot, once you add all of these, right, or find the percentages, they should all add up to 100%. And that's it.